Hey everyone, this clip you're about to watch is from my new video on bug bounty hunting for client-side injections. It's part 2 of the series and it's by far my most requested video. I've got about 4.5 hours done so far, and I tell you, I'm gonna stop trying to guess the final length because every time I record a little more, it keeps going up. I'm not even done with the first of the 3 hunting sections that are gonna be included, although hopefully we're getting close to the end there. So anyway, hopefully these clips will help get you started while you're waiting on me to finish the rest. I hope it helps. Cheers. All right, so the first thing that we're gonna do is we're gonna go to my GitHub and we're gonna download the repo for this video. And this is something that I wanna start doing more. I built out a couple things. There's a script that's gonna help us find programs that are gonna be good targets for client-side injections. There's an app that I've built, not necessarily an intentionally vulnerable app, but more of a lab environment where you can go in and set different security controls and test out different payloads and see how they impact and everything. So we'll play around with that a little bit. And then it's also got the slides for everything that we just saw. So you want to go back and you want to get the actual image version of the slides, go and review those yourself. Obviously, there's a lot of additional information that I did not talk to or through in those slides. You can go and get that as well. So, but let's go ahead and we'll just go to GitHub here. So github.com and we'll go straight to my page here. Yes, I know I go to GitHub a lot. We'll just go up to repositories and right here, client-side injections part 2. So I just got it built out a couple days ago, and yeah, there's some good stuff in here. I'm pretty excited about starting to do this more and more as I keep making these videos. So let's just come over here, git clone, add that in. We will move into that. We got everything, and I'll just go ahead and get VS Code brought up here. It'll be a little bit easier to work with. Okay, so yeah, like I said, you got the slides in a zip file here. You can open those up and you can unzip it, take those out. The README for the vulnerable lab here, along with a little bit of information on the script, is included, so you can go through and read all that, figure out how to do it. And then our find programs directory here does have the script that we're going to use to go ahead and find good targets. So, and if you remember, like I said, if there's one thing that you take away from this video, outside of all the client-side injection stuff, just please remember this. The successful bug bounty hunters that I have seen, and this is the way that I was able to find success, you do not go and find an individual program and then do basically a pen test on that where you test all these different client-side injections, server-side, right, all these different attack classes. The successful bug bounty hunters that I see, they pick specific attack classes and then they search across all the public programs and private programs that they have access to for good targets based on their technology stack and everything else. So we're going to start with this XSS target finder script that I've built, and that's exactly what it's going to do, right? So, and actually, let's go ahead and go down here to the bottom. So you can give this both your HackerOne and your BugCrowd API key. I'll probably build some more in there as well, but I just wanted to get something out there and working, right? So they're done with environment variables. You can see that what the naming convention is there, and it's also in the README, and I've actually already got it set up over here. So within this instance of the command prompt, I've gone ahead and stored my API key for HackerOne in the environment variables there. So what this script is going to do is it's first going to go through and build out a JSON file with all the public data for public programs on here that it can access. So HackerOne will go through and find all the public programs. It'll get the scope for it, some additional information, etc., and it'll store that locally. Once that's done, it's going to start picking programs at random. So every time you run this, it'll work a little different. And if you've already got the program data there, it'll check first to make sure do you want to update the data or do you want to use the one that's already there? If it's data from a day or two old, right, there's no reason to go through and update it. Anyway, but it's going to go through and pick random programs, and it's going to identify, first of all, any scope targets that are just a straight URL, as well as any wildcards. Now, depending on the flags that you give it, and I don't want to dig into a bunch of stuff here, but you can, for the wildcards, you can give it a flag that will tell it to use certificate transparency logs to reach out and try to find additional subdomains that we can test. We're not going to worry about that right now, but by default, if there's a wildcard, it will just convert that down into basically a domain, right? So if it's star.grammarly.app, then it would just test https grammarly.app. right? So kind of a simple thing there, but it reaches out and it does some basic inspection on that. The main thing it's looking for the client-side injections is it's looking for the client-side technology stack, right? Does it have a lot of custom JavaScript files? Does it have is it using React or Angular or anything where we're going to have to get this really specific thing, or does it not have a client-side JavaScript framework? Does it have jQuery and all these other things that are going to give us a lot more opportunity to go in and actually find some potential client-side injections? So the script is going to do that. It runs consistently and it builds out a text file as it finds new targets. So what I typically do is I'll let this run for, it just depends on how long, but a couple hours. Give or take. And as it starts to build that up, then we'll be able to look at it. You go test them one by one. It also gives a really basic numeric score based on, it's between 0 and 100, based on how likely it thinks that this could have potential client-side injections and how, we can weaponize it too, right? It checks to see if there's any login buttons on the main page or things like that, because if there's authentication, there's going to be a lot more opportunities to weaponize, etc. So what we'll do is we'll get this script running. We'll go through and have it find the programs. And while it's doing that, I'm going to pull up our lab and I'll do some demonstrations of how you can use it to do your own testing and your own training and everything. I'm not going to go through every feature in there because I've actually built a lot into it. But it'll be available and free for you. Go clone the repo down. You can play around with it yourself. And there's a lot of verbose instructions and information and learning materials within that to explain what's going on, what code patterns are actually vulnerable, et cetera. I really wanted to include as much of that as possible. So let's go ahead and do this. Get this up here. And then first of all, I think everything's already installed, but what do we have? Let's go into our find programs. And then we will do pip install attackr requirements.txt. Okay, so yeah, you can see I've been testing this. I already have everything installed. That's why you see like requirement already satisfied, already satisfied. Yours will look a little bit different, especially if you're not installing on Windows, which I'm doing all this on Windows right now. But it is pretty basic, right? You just install the packages. Hopefully, if you have any issues with this, simple Google search, Google Gemini gets you squared away. So I'm not going to worry too much about this here. From that, let's see, we can just do Python 3 and XSS find target there. And then we're going to give it a couple flags. Let's come back here and take a look at what the flags are that we can use. So here's a few. Oh, no, that's for the wrong part. I forgot where I put the code. That's going to make it easier. Okay, here we go. We got the parser. Oh, I thought I put it in a different function. Oh, that's fine. So here we can see the flags, right? Now, by default, it's going to check for a HackerOne and a BugCrowd environmental variable. If neither are there, the tool just exits because it can't do anything without either one of those, or if the existing JSON data is not there as well. You can tell it to do only HackerOne or only BugCrowd. So that's what you see right here if you want to tell it. We're going to skip those, though. We also have two different main modes that this tool runs in. So there's the reflected, stored, and the DOM base. So the targets for reflected cross-site scripting and stored cross-site scripting are going to be a completely different technology stack and completely different things compared to DOM-based. So DOM-based cross-site scripting and then client-side prototype pollution as well. So we have two different ways to run this. We're going to start right now with the reflected and stored cross-site scripting because that's going to be the first half of this hunting section. I'm going to go through and we're only going to focus on reflected and stored cross-site scripting. Then we're going to come back to this script later and we're going to run it for the DOM-based checks. We're going to get a whole new list of targets and we're going to go in and test those. And those are going to be ones with a large number of custom JavaScript files. They are going to potentially have some of those like Angular, React, everything. Whereas now with the reflected and stored, it's a big bump in the score if it does not use that framework because it's more likely for us to find that specific class of vulnerabilities. Again, decide what type of vulnerability you want to hunt. Find targets that are good targets for that. If you want to do one thing to give you a huge boost in your percentage chance to actually find valid vulnerabilities and stop wasting time, that's it. Again, if you forget everything about client-side injections that I teach in this video, take that one thing away. It will have a profound impact in your ability to find bugs. I promise. Okay, and then you can also tell it subdomains. Again, that's going to inform it that either we want to use the certificate transparency logs, and if anytime it finds a wildcard, I'm not going to bother with X. We got plenty of different targets. And then you got verbose as well. I like to run it for verbose, but that's really it. So our command, we'll tell it to do just HackerOne because I only have that API key in there, and I don't want it to even have to go and check. I'm going to tell it to do reflected stored, and then I'm also going to run verbose because I like to do that there. So let's come over here, and we will go tac HackerOne, tac reflected stored. It would be fantastic if I could type. And finally, verbose. So let's go ahead and get that running. And here in just a second, we should see that it's going to start. Interesting. Let me figure out what's going on. We'll get that fixed. Okay, so today I learned, and I'm doing this on Windows, right? Remember, it's a Windows command prompt. Today I learned that if you use set X instead of set, which set X on Windows sets that environment variable system-wide as opposed to set would just set it temporarily, then you need to actually restart your command prompt before you can access it. I did not know that, and I just learned that right now. So that was the reason that the tool didn't work is or at least it didn't find the environment variable because I needed to restart the command prompt too. So let's get back into, where are we at? How do we end up back here? Don't know, but that's fine. Find programs, started to type fine as I was saying fine. Funny how stuff like that happens. Okay, all right, so we should be good now. So once again, we're gonna do Python 3. We're gonna do our Python script. We're gonna tell it HackerOne. We are gonna tell it reflected stored. And finally, we're gonna tell it verbose. And okay, perfect. So it is reaching out. It's going to take a little bit of time because it's a fairly large JSON file and there's a bit of data in it. So we will let that run. And in the meantime, I'm going to come back over here to finding account takeover, $10,000, $15,000 bugs because you're taking the time to understand the application and you're finding those ones that other people just don't go through that effort. And so they're never going to get to the point where they can even get close to it. All right. Okay. Have fun with that. Really hope it's helpful. Let's go ahead and move back over here and let's see what we have found. So you can see this is running through. I was looking at 8x8, which is a program I've actually tested on before. All right, you can see some of the different things here. So this is a 95. For this one, that's good. It's not finding any, no virtual DOM frameworks. We got a couple of custom JavaScript files there. So you can see with the 2 custom JavaScript files bumps it up to a 95. Otherwise, it's with none, it's down to a 70. And you can see some of these. So nope, that one has React. That's not a good one. But all of this data is being added into an individual file. So what I'm going to do is I'm going to allow this to run for 3 or 4 hours here. And I will come back next time I have time to record. I'm doing, bit by bit, aside from the presentation was something that I did on Sunday where I actually had the time, but I'm trying to do this in blocks of 30, 45 minutes in the evening, go through and edit and stuff to get it built out. So yeah, I hope it's helpful. Again, enjoy the lab. When we come back, we will look at the results and we will start actually testing on real bug bounty programs for client-side injections, which I'm excited about. Cheers. And we are back. I had the script running for about 24 hours. Now it's been a couple days since then. I just haven't had time to come back and record again. But it looks like we've got a lot of results. So let's go ahead and start looking into them. And once again, as I keep saying, we're going to use this to reach out across all of the different public programs, or several of them right now that we've tested on HackerOne. And we are going to identify targets that, based on their technology stack and the way they respond to certain HTTP requests, appear to be good targets for testing client-side injection, right? And again, if there's one thing you take away from this video, that's something that I want you to take away. But let's see what we've got here. Go ahead and list it out, and we can see our results files, that txt file there. So we can do cat XSS targets, and let's see what we got. So you can see the output here. We've got the different individual URLs on the left-hand side. So these are the targets that we want to look at. And then we have a score in the middle from 0 to 100. That score is based on as I said before, things like custom JavaScript files, whether or not it has a web application firewall, content security policy, does it have a virtual DOM? All of these things come into play, and we can see there's some, like this one right here, that has a score of 95 out of 100. So that one we can assume is a very, very good target for client-side injections, whereas this one down here on Coinbase has a score of 15, so probably going to be much more difficult to find one on those. And you tend to see some trends as well, right? A lot of these here, 50, 50, 50, 50. So these different URLs, these different applications are probably all using a very similar technology stack. I think if we come up here a little bit, you know, again, you typically see it, right? John Deere, we're seeing a lot of 65. So you'll start to see some patterns as you look through it. And more importantly, you're going to start to see those patterns as you test across the different technology stacks. You're going to start to figure out what compensating controls work, what don't work, what's an expected pattern, what's an unexpected pattern, etc. So, and I do have the program in here as well, obviously, so that you can go and check that out. So if we look at the bottom one here, you know, this is a score of 95. That's very good. So I would want to go ahead and open this up, and let's take a look at the program itself. So this is SEMrush. I have not tested on SEMrush, I don't think. If I have, I don't remember any reports I submitted, so it'd be a while, but just looking at the metrics, it's pretty good. We've got response efficiency of 100%. They've been going since October of 2017, which, good grief, is almost 10 years now, as wild as that is. But so they've been doing quite well. Now we have a wide range of bounties here. It's kind of a mid-range target as far as bounties go, but that's not bad at all, especially if they're very generous when it comes to these low bounties, right? Especially if they're giving low bounties for things like compensating controls or something that maybe doesn't have an exact way to weaponize it today. But it always depends, right? Whenever you're working with a new program you haven't worked with before, you always want to submit a report or two, get an idea of what it's like to work with that team, because that's what it is, right? You really are coming together and forming a partnership to work to resolve these vulnerabilities. And, you know, from the researcher side, you want to work with companies that want to work with you and want your advice and everything. So that's how I would probably approach this, but this looks good overall. You know, you can see the response, 4 hours, 1 day, 1 week. This is all very, very good. So I'm pretty bullish about this one specifically. Now I use the HackerOne API to go in, so I don't expect any of the results from the find programs or find targets script in here to be out of scope. It also checks to see if they are live URLs, if they're actually responding with the 200 response. So I wouldn't expect to see a bunch of forbiddens or a bunch of things that are not responding. All that should be taken care of, but I definitely recommend once you run it, just come in real quick before you really start testing on anything and make sure that the domain is included within the scope, right? We can see the one that we're looking at here. That's it, right? SEOAB.io. Yep, so 95. It is a high, so not one of the most critical ones, although good that it's not the one that's ineligible for bounty there. And definitely not included in one of these that's out of scope. So yeah, I don't, you know, I do that once I start doing any real active testing. We want to make sure that everything we're doing is in scope, but we can go ahead and at least put everything in burp. Yeah, again, the script does provide some reliability for that, but just please be careful when you're doing it there. So I don't know how many results we got. We got a lot. Does it go all the way up? That's a good number. Tell you what, let's see. Let's do word count tac L, which is going to show us the number of lines, and we'll do it on our same file there. And it looks like we have 1,038 targets. So that's great. That's a lot of different opportunities for us to go in and test. And we'll do automated and manual testing. Although the automated testing, I'm not going to use active scan to throw a bunch of like cross-site scripting payloads across or anything. That's not what I want to do, but I am going to use active scan to look for things like reflected user controlled input very quickly while I'm going through and finding manual targets for that as well. And that'll especially help with finding the reflected user controlled input that might not be as common. Right now, sometimes that ends up being a header, and that ends up being a cookie or some of those like attack vectors that we don't expect. And in that case, we're going to have to figure out how to actually deliver that to a victim. So whether that means getting some way to write a cookie through a JSON or a JavaScript injection, something within the DOM, potentially a CLRF injection to where we can, what you're doing is injecting basically a new line within the byte stream to trick the application into returning a header that you're inserting as part of a GET request or a hash fragment or anything like that. And we can see what that looks like in a little bit. But anyway, got a lot of different opportunities. We will start with going ahead and populating burp here. And I'm going to use bash to do that. So let's grab this one here. And I've already got a few written out for this. I'll just come and paste it so we can look through. And we can use this bash one-liner to go through. And first of all, it's going to use grep to identify any URLs within our new results file, right? The file in here. So that's going to grab all these. It's also going to grab all of the HackerOne files, which we don't want. So next it's going to pipe that into grep. And now it's going to do a reverse grep to pull out anything that does not match this HackerOne domain here, right? So that's going to filter out all the ones here and only leave our individual URLs that we want to send a GET request to. And after that, it's going to set up a while loop. While is kind of cut off with the thing there, but that's fine. To read each one of those URLs, pass it to curl, and then curl is going to use the tacx command here to pass that through the burp suite proxy at localhost 8080. And then just check to see, right? It sends the output to dev null, and then it will let you know if it was successful or not. So this is a very easy way that we can use just a simple bash one-liner to go through, pull all of these URLs out, and then use curl to go and send it through. And this will populate burp with everything. And then we can use all of these URLs once they're populated in burp to go through and run an actual scan on them. So let's let it go ahead and start doing that. And immediately we see our proxy catches it. So let's turn our proxy off. We come to HTTP history, and we'll see them start to go through there. So it is going to take a little while, right? Curl, we're getting some 302s also, but that's fine. I can continue to do that. Oh, Flowcast came up as well. Flowcast is my own company. I actually built that program. I think I mentioned that earlier. I know I did earlier. Yeah, you've heard me say that. Sorry, I'll shut up. All right, this is going to take a little bit. In the meantime, maybe I should, can we do a new tab here? I always forget how this works. Maybe we cannot. Okay. Let's just do a whole new one over here then. That'll be fine. I'm going to bring it over here while that is running. I'm going to go. Okay. Okay, so I've got us back in here. I'm going to go ahead and just read this. We can start clicking through them. So while that script is running in the background to go through and populate burp, I'm going to start clicking into these, and I'm specifically going to click into the ones that I think have a really good score on here, right? And then in this git bash, let's maybe just come over here because it doesn't really matter. You can just hit control and click it, and it will open right up. Now, interesting. That's what happens when you load the... Interesting. Okay. So I can see, I probably need to add a little bit more logic so that I make sure that it's an actual DOM and not that, but who knows, we may be able to get something injected in there. So let's check out this winstream.net. All right, so here's an actual page. Stays on winstream.net, right? So we can do search. And as I'm going through, I'm just going to manually start to populate burp. You can see here that I've got Foxy proxy running. It is, let's see. There we go. Now it's running through burp. That's probably better. Oh, it's a search. I was like, why is all my stuff coming up? Okay, so then go back here. So it's like you know, I didn't even see the thing, search the web. I wasn't even paying attention, but I just want to make sure. So we got it going through burp now. So I'll click on this here. And if we come back over to burp, we should see, yeah, there it goes there. So now we're starting to populate a little bit more with the actual areas where we know that something's being reflected, right? So we've got a get parameter here. We have user controlled input that's being reflected. We obviously have it several different places within the web results here. So already we're starting to see a good target for client-side injection, for cross-site scripting, right? So how we would, if we could find this, we'd go script, gosh. And now we have found that we have a web application firewall as well. Okay, so you know what? This is good. We want to go ahead and start getting our notes set up here. So let me click on this, and this is going to open up. I'll bring this over here so it doesn't clog everything up. And I'm just going to do let's get you over there, get you over here. We're we're going to get you away. Don't need that. Don't need a terminal. All right, that'll work. So we will do client-side injections part 2 notes right there. And then I'm going to split this up into 2 different categories, because what we want to do is we want to start identifying attack vectors for cross-site scripting. So this is one attack vector. We have it in a get parameter where we see it's reflected. And then we want to start documenting what the compensating controls are that are going to prevent us from actually being able to get that client-side injection. And we found one right here. So first of all, to get our target, we'll go back here. So, and that actually needs to come down here. And this will be reflected and stored XSS, right? Because that's the first category that we're going to do. And there's going to be another category later, DOM-based XSS and CSPP, client-side prototype solution, and we will get some going there. Okay, so I want to make sure before we start testing, because again, we have found our attack vector, the attack vector. An attack vector for client-side injection is there is user-controlled input that is reflected in the DOM somehow, whether it is immediately reflected in the server response, whether it's stored in a database and pulled out later, that would be your stored cross-site scripting, whether it's reflected or, let's just focus on those 2 for now, right? Because the DOM-based cross-site scripting is a little bit different. But for here, we're just focusing on user-controlled input. So that's coming from an HTTP request that's being reflected. Now remember, if we get this to alert, if we get JavaScript to execute, we need to figure out how we're going to deliver it to a victim. So we have already found a way. This is our user-controlled input. That's our canary. That's our payload. So if we can get somebody to click, if we can get this to execute, then we can put our payload within the URL and we can deliver it to a victim. We could set up a malicious site that would redirect them over there. There's a lot of things that we could do. And I still, I think it's cool that all this stuff is coming up. I guess it's probably just using the same type of thing that that Google is, but indexing its own stuff. But okay, so we have found a potential attack vector. I want to go back and I want to confirm that this is within scope. Again, just be cautious. My script should handle it, but you never know. And let's also just look at the thing in general. Response efficiency 100%. Now, I'm not seeing any bounties on here. So this may be a program that's more of, yeah, it is right here, a vulnerability disclosure program. So unfortunately for this one, we are not going to get paid any bounties. However, it's still great to test on these if they have good metrics for response and everything, because this can get us, once we do find vulnerabilities, it can get us invites into private programs. And that's where you can really make a lot of your money, right? You want to get into those private programs that have much less testers on there, and then you can go in and hopefully find parts of that application or domains in that application within scope that nobody else has tested yet. That's usually the goal you're getting into. So still a great target to start on. Let's come over here to the scope and make sure that there's nothing that we're missing here. So it is the search. We're definitely within scope there. Let's just make sure in the out of scope. No. Okay, so we're not seeing anything about the search. And I wouldn't expect that because this is the main root domain. So yeah, so this looks good. This looks like a good target. We'll go ahead and minimize that there, and we can get Burp Suite brought back up. That's totally fine. It's still running through each of those. And we'll come back here. Okay, so we have that. Now, again, we want to start probing. Let me just bring this over. It's going to be easier. We want to start probing for the different compensating controls. Okay, so we already did that once. We came up here. We'll grab the Q. By the way, Q is a very common parameter for searching there. And we're going to do script alert1/script like I did before. We will run that, and we get blocked here. And this is a Cloudflare WAF, Web Application Firewall. So let's come up here. WAF. I don't know. I don't have any specific format for my notes, if you can't tell. I just kind of make them up as I go. So Web Application Firewall, yes. Cloudflare. And then under here, we want to show what is triggering it. So let's see if we can figure out what this hits and what it doesn't. So let's get rid of the script tags. Come on. And it allows it to go through. So we'll just say that removing script tags equals no block. What about an open and a close right there? That's fine as well. Okay, so it is not checking for the open or close. It's not checking for alert. I'm guessing it's checking for some actual payloads in here. Let's just try. Let's try just one script tag, see how that works. Okay, that one's blocking. What if there's a plus in the middle? Still blocking it. And, Cloudflare as well, there's a lot of known blocks, so we can look for WAF bypasses with that will be the next step. But I'm kind of just trying to probe because they can go in and manually configure this based on some certain things. I'm hoping that they have use cases where special characters need to get through to where we can potentially, break that. What if it's got a U in the middle? Okay, so this as well. It really looks like it's just looking for a script tag. I'm not going to do this all day, by the way. You just want to probe. We're starting to get an idea. Again, we got so many different targets. We don't want to get bogged down. We're just starting to kind of dip our toe in the waters and all these different things, all these different programs, and we'll start to see the patterns. We'll start to see the ones we want to dig into further, etc. So let's just maybe one other thing here. Let's see how it likes an image tag. Let's get rid of all the rest of this and let's just do an actual image tag. Just do something like that. Super simple. Okay, so it is all right with that. Image source equals that, on error equals alert 1. Let's see if it's picking up that pattern. Okay, and it is picking up that pattern. So come here. I'm just going to grab this. That's probably all the context that I need right now. But we can see it's not checking for, like if it was blocking on just including an open tag, close tag, right, greater than, less than, whatever you want to call it, then that's going to make it much more difficult to circumvent. But it's also really hard to do that. This I actually kind of expected to block, and it didn't, because it's just, why would you need to send a full HTML element, even if it's not a real element? But anyway, so it looks like there's some daylight within that compensating control, but obviously this is going to have a big impact on our ability to actually get those payloads through. So let's come back here where we have everything working. And let's see if we can probe for some other compensating controls. Let's go back to script. To check some client-side validation. No, that's fine right there. All right, how about, because we know we can send these, let's just see if we are getting output encoding. Oops. And we'll just focus on this one right here, first of all. So it doesn't appear that we're getting any output encoding. Let's just do this. Let's come up here. I'm going to go arson right there. We'll click that. And I want to check within Burp Suite because as we saw before, can I get back in there in time? Grab it. Okay. Send this to repeater. Go ahead and send that through. Let's search for our arson canary, which actually is popping up. Okay, we've got this coming in a lot of different places. So output encoding. Yes, at least in some places. So we have the title right here. I want to turn this into a one-liner. We don't need all that extra white space. There we go. Okay, we'll keep clicking through these here. And here, this is great. So you can see we've got some different types of output encoding. Here we've got it coming through the HTML. And this session payload, So the session ID is written in the DOM. That's when we're talking about weaponizing. Again, I assume this is session ID, and I'm not logged in, so we need to find out if, if it even makes sense to log in. That's something we'll check in a little bit. But the output encoding is definitely very different here, which I would assume is so that we can't break out of this JSON. Because what we would need to do, the only character that would work in this case is a double quote. We would have to find a way to inject a double quote. Now the Unicode coming in here is interesting. So that is, obviously before it's being sent back, that is the output encoding where it's converting those to those Unicode characters. I'm just going to grab this in general. Let's just drop this off. That'll be fine. Okay, and that's all just one thing there. Good. Okay, so we're seeing some output encoding, but they're different. And I definitely don't think what we're seeing is, do I have Wappalizer on here? No, I don't think we do. Let's see if React is mentioned in here. That's not what I was thinking. This looks like something that's coming from the actual results or something. I don't know. But yeah, I don't think this has, it's not looking like a virtual DOM at all. Let's come back over here to Burp Suite and see. Oh my gosh. Okay, let's make this bigger. See, go work. Where are we at? Where are we at? Made me lose it. Oh, and then here. Huh. Was that our session ID that we just grabbed? Where's our notes? No. It's not. Okay, I was gonna say that'd be pretty wild. I don't know what this SC parameter is here, but we can see another output encoding where this is being embedded into other URLs that can be used. Yeah, and then we've got the hex encoding here, so that may be, it's actually very difficult to do that or to break out of this if it's coming from a get parameter, but we'll mark that as output encoding as well. Let's just get the whole href here. Copy that. I'll probably have to leave this open. Just keep opening it up here. All right, let's keep going. So we've got a bunch of different output encoding, and this is great because this gives us an opportunity to try a lot of different ways to circumvent this output encoding. We've got 3 different ones right off the bat. So maybe something won't work to circumvent this or this, but maybe I can break out of this one here, right? So there's a lot of complexity here for their security team to deal with. This is very, very challenging to come in and make sure that the output encoding for all these different use cases, all these different types of encoding is going to prevent a working cross-site scripting or a working client-side injection. So this is certainly the type of thing that I want to see. So the second target that we looked at, the first one that we're actually digging into, is already one that is getting me very excited considering we're looking for client-side injections. Let's keep going down, see what the other ones are. We'll have a lot of these here, more HTML encoding. Now this, where is this coming from in the actual thing? I don't know if this is actually from that there. That's one problem with doing the search where it's pulling it back. I don't know if this is actually being reflected. I kind of don't think it is. Because if it is, it would mean that it's stripping these off, and that's going to be a... let's do this. That would be a server-side validation instead. So I want to just do a completely random canary that I know is not going to be there. Copy this. Shouldn't give us any search results or anything like that. Let's do this. And now let's see where just this completely random piece is. That's the input. So this is going to be that search form on the top, and we can see it's being added in the value. So let's actually grab this one as well. This is good to know for our notes. Although I would say this is going to be the most thoroughly tested attack vector that there is. Anytime there's a search engine or any search that goes through and that search result is reflected as the value in the actual search bar, this is like the #1 place that people test. So I never expect to find anything here. I will just add it for the sake of it. Let's see. Did I copy that? I did. And then I just want to put in parentheses here, search bar at top, so that I know that. All right, let's go back to trying to figure out whether or not that was a something from search results or something that was actually being written there. Now this, okay, so we're in between an HTML tag here. We are again seeing the output and quoting, but this is a really, really great attack vector too, because we're out in the open. So if we can find a way to circumvent this output encoding and actually get a greater than less than to be written in there, then we could have a lot of opportunity. So I definitely like to see that. Let's come and add that to our notes as well. All of these are telling me, showing me and telling me that this is going to be a good target to do some thorough testing. And because they don't actually pay bounties, there's probably not as much testing as there would be if it was one that actually paid very good bounties. So again, we can do that, focus on those programs that don't pay bounties, get a couple valid submissions, that'll get you invites to private programs, that'll get you a much higher chance of being able to actually find or get a higher bounty, especially if you're getting started. I would definitely focus on those. So without the arson in the search results, we've got 9 different ones for this very unique canary. And I think that's a good start. I'm not seeing any evidence of server-side validation right now, but that certainly doesn't mean that it's not there. It definitely looks like output encoding is one of the main things that they're relying on. And let's also take a look at their content security policy, which I'm not seeing one at all, unless it's written in a metadata here. Anything? CSP. I don't believe they have a content security policy. I need to poke around a little more because again, content security